All right, before the break, we were looking at some collection things about collections. I they're actual those are module three assignments. I want to jump ahead because I kind of consider a collection part of the basic syntax. We're going to use that in our most fundamental programming levels, along with writing files. We're also going to look at a couple of quickly look at file writing tonight. And there's another thing about comprehensions. But in the comprehensions and generators, which are an improvement on list, um, during the break, a question came up about the discussion board this week. And if you haven't looked ahead, I'm going to open GitHub for a reason. We'll see in a moment. If you haven't looked ahead, one of the things you're going to do with the discussion board is share the code with your classmates. It's about desk checking. That's where you do it by hand and grab a paper and pencil and act like you're the CPU and write down what's actually happening at each line of code, not what's supposed to happen at each line of code. Because if you write down on the paper what's supposed to happen at each line of code, obviously it's going to work because but it's for when checking, looking for your algorithm getting all. But yeah, talking about desk checking, advantages of that. Has anybody posted to it yet? No. So I can go ahead and do that here. When you make your reply, there's a little video here up here. Watch this. But one of the things it's about other apps. Since you're sharing your code with your classmates, I put a little video in there. Watch that when you get a chance. But there are other apps that are available. We have better options than just typing in there. So we can embed code directly. That's obviously useful if you're sharing code. Embed that, and then it will do all the lexing. If you haven't heard that word before, that's the color changing, predictive text, the verb form of lexicon of a language. So all of our lexing stuff, it will do that for us. Might be code highlight that does that. Actually, might be code highlight, and then you type your Python code, and it'll change colors right there in the discussion board. But there's also a GitHub link here, so might as well show you all how to use this one. Basically, we want to embed some GitHub content, and this one threw me off at first. It took a couple tries. I thought it wasn't working, but when we add the full repository name and out of habit, I kept coming over here, grabbing the repository. So where's our last repository? SDEV 220, spring 2024. I'd always come over here and do like you used to and grab the whole URL and copy that. But it only wants the name. So you'll only need your account name and then that repository name. And yeah, that threw me off for the longest time. And then it posts the summary of the repository. It gives information about it as well as the link to it. I'm going to delete this in a second, but then you can see, since you're sharing code with your classmates, that's probably a good way to share the code. And links right to it, and they can read the code, or the code highlight button. I believe I turned your edit buttons on. If you do not see the edit buttons, whoever looks at it first, please let me know. Because your edit button, you should have the edit buttons on the discussion boards, which is an important one here, right? So we can also use the code highlight plugin. Plugins are down here now for some reason. I think code highlight is the one I was looking for and write Python code. Maybe. Went way quicker last time I did this. Cancel that. Or cancel that. Let me check code embed. Make sure it's not code embed. I can't really remember which one it is. Let me try code embed. Nope, that looks like it's not working. So hopefully it's code highlight. Okay, there we go. Stuff is loading in this time. I don't know what was going on a second ago. Maybe. It looked like it was loading. Okay, mine is not loading for some reason, but code highlight plugin is the one that you would type Python code and it would change all the do the lexing, change the colors so that it makes it nice and makes it nice to read the code there in the discussion board. Can we try it one more time? Really? I've seen something different now 3 times. I've clicked that button, so I'm not. When I tried it before, it just loaded right up, and there was a spot to type code. So I'm not really sure what's. Yeah, I don't know why it's doing this. Try that later. That's got to be on Ivy Learn's end. Uh, the code should be better. And if you do not see an edit button on your thing, let me know. You all should have the ability to edit the discussion boards. I'm going to delete that post, but those other apps are there. It can be useful. So make sure you do the case study sooner. It should be fairly straightforward. Shouldn't be too difficult. If you pass the prerequisite courses for this, it should come together pretty quickly. And then you'll kind of like talk about desk checking. That's the manual check. Grab a pen and piece of paper and act like you're the CPU to try to track down problems in the output. What are the benefits of that? What are the drawbacks of it? And that's the discussion part this week. So now we can get back to list. So maybe we want a list of we had all right down here at the bottom list, comprehensions, and generators. You probably didn't see these in the previous class. So what if we wanted to say a list of odd numbers? The odd numbers between 0 and 100, right? Y'all could probably come up with an algorithm to do that really quickly. For I in range 0 to 100, so 100 is even, so it'll stop at 99 there. 0 to 99. We just need to see if it's odd. If I mod 2 does not equal 0, right? If we divide by 2 and have a remainder of 0, then that means we have an even number. If we divide by 2, the only other option is a remainder of 1. So I guess we could say if I mod 2 is equal to 1, but at least the way my mind works, it makes more sense. Think of the even numbers and then the other ones are odd. So I would do if we divide by 2 and there is a remainder, then that means we have an odd number. So I'm going to make a list called odds. And then we go through here and odds dot append that I that we just checked. All right, that'll give us a list of odd numbers. You can print it out. Nothing too fancy there. Let me print a bunch of line breaks and some sort of a barrier from all the earlier outputs. Instead of going back and commenting things out, I'll just add a little some sort of break in the outputs. What? Did I spell that wrong? Oh, whoops. Parentheses. Sorry. Not index I. We want to actually use the append function and a parameter in the function. There we go. So you can see that gives us the odd numbers. But there's a more concise way to do that. So that's where our list comprehension is. Whoops. So instead of doing that, I'm going to, what was that? Edit comment block is control 1. Okay. So I'm going to highlight that and hit control 1, comment it all out. Actually, there's a better one on there. add a block comment can be useful for labels. Control 4, and that gives us a nice little label spot. Might as well point at that. Get rid of this, because we can do this more concisely. So we know we're going to make a list. So we want to walk through some sort of list. So square brackets, like we're setting up a list again, and then I'll say I for I in range 100. I'm going to need commas here. Nope, no commas. Sorry, the syntax looked wrong when I looked at it, but sometimes languages blend together for a while. If I mod 2 does not equal 0, so if we divide by 2 and there is a remainder, we'll put the I into the list. See how we got the same list that way? The same stuff. That's why I like to do that for loop first, right? We want I, or maybe we can, if we want to enumerate things, we could set up something like I, comma J. We put that in parentheses if there's several of them, right? If we have a collection like that enumerate thing we saw earlier. But we want the I, and that I comes from that 4I in range, and then our condition, and we put it all in the list to begin with. So instead of appending to the list or building the list, we just put in the criteria to make the list. That's what's known as a list comprehension. Inside the square brackets, we put the instructions to make the list, because obviously that's something that we do quite often. A generator is similar, but what I'm going to look at is, notice odds. We have that list. The computer went over, reserved some spots in RAM. I erased that diagram from earlier, but it reserved a bunch of spots in RAM and stored all those values as a list. So each one has a pointer to the next one. It's using a lot of RAM. Also have, I'll do the same thing, call it not even. Well, I'll copy the whole thing, all those criteria. Probably the easiest way to do it. That way it's consistent. I'll use my shift key and arrows to copy it. But instead of square brackets, I'm going to use parentheses this time. And this is what's known as a generator. Print not even. Notice the list all printed out. The second one, if we look over here, we have the list. We have the same instructions, and it just says it's a generator object. So instead of printing that out there for O, I should not use O, in and not even, print in. So now I'm trying to loop, right? This doesn't show us a list. We can see that right over here on the screen. It says we have a generator object. Same instructions as we used to make the comprehension. But if I put that here, like it's something we're going to iterate through, we do still get all the odd numbers. Notice they're not, but notice they're nowhere in RAM. So instead of storing the list, a generator just stores those instructions on how to make the numbers we want. And then we go to like a loop. When we go to loop through it, then we'll grab the numbers we want as we get them, right? So maybe we want to know the odd numbers that are also divisible by 7. If in mod 7, so divide by 7, whoops, and we do not have a remainder, then those are the ones we want. Which odd numbers are divisible by 7? That sort of question. We don't have to fill up RAM with all the odd numbers. We can just generate them as we need them on the fly. So we're not, and obviously if we're just replacing integers, right? We find integer 1, stick that in a spot in RAM, and we're not keeping them. So when we get to 3, we can reuse that spot in RAM. And then when we get to 5, we can erase the 3 and reuse that spot in RAM to store 5. So it's much, much more memory efficient because we're generating the numbers on the fly as we need them. So there's our numbers. I thought that was a 31 for a second. It's like, wait, somewhere wrong. But no, I thought that 21 was a 31. But yeah, those are the numbers divisible by 7. But we found it by getting the odd numbers first. And if we ignore the earlier example, we did not store the odd numbers anywhere we didn't waste a whole bunch of RAM storing all the odd numbers, right? If we increase this to say 10,000, we're not using any more RAM because we're still in those 32-bit ints, kind of like we talked about earlier, beginning of class tonight. We haven't passed the 32-bit integer range. So we only need 32 bits and we're doing them one at a time. And so we can keep reusing that same 32 bits in RAM. So going from 0 to 99 and 0 to 9,999 did not use any more RAM when we used a generator, as opposed to a list, because a list would have used a whole lot more RAM, right? To go from 99 integers, half of 10,000 is 5,000. So to go from 50 odd numbers to 5,000 odd numbers is going to use a whole lot more RAM if we keep them around the whole time. So generators can be very, very useful. And also, you notice how we're talking more about what's happening on the inside of the machine tonight? Kind of like there, I just kind of assumed you all knew what those algorithms were doing, or could make that yourself. You know, I've done it many, many times, so I don't think I did it correctly the first try, or odd times throughout. Might have done it, didn't do it correctly the first try, didn't do it correctly the 58th try. Typos happen and stuff. So, but I've done that a lot of times. But I have no doubt that y'all come up with that algorithm, right? I said, give me all the odd numbers up to 10,000 that are divisible by 7. You figure out something pretty quick. But unlike your previous class, we're not focusing on the algorithm. We're focusing on this tool and kind of talking about what's going on internally. So it's the transition from 100 to 200 level programming class. I thought I'd kind of point that out explicitly because we want to think about some of that things. What would make it better, right? Where's your software being written for? Are you going into like some sort of healthcare setting? Are you writing software that's going to be in a healthcare setting where lives depend on it? Because in that case, you probably want to make that as efficient as possible. You want to make that run as fast as possible. You want to make sure you have the absolute fastest possible software you can get to get that output to the doctor before the person's next heartbeat. You don't want it slowing down there. Things like that. So those considerations do come up, but generally that's more of the computer science side. In software development, software engineering, we just want software that works, and works is works. So yeah, machines are getting faster every year, so not too big of a deal. I just wanted to make sure and express the point because it does still show up in our world, especially when we get to massive, massive data sets. But comprehensions and generators are very, very nice, very, very useful. Let me point out something on GitHub. An example where I use those to great effect. So for game development, I've made a lot of humans over the years. Finally, I just made a Python script that did it in Blender. So I had a full character. Oh wait, that's extended beyond that. The man and the woman, full woman, are like clothed, and this is a starter thing. It's not a complete final version, but everything's set up ready to start, finish. And if you've never seen it before, let me download this. And nope, not open that way. I guess I'll go in this way and open it. Mostly, I just wanted to. This is what 3D graphics look like in Python encode. Open with Sublime, so I can turn word wrap on. So a 3D model is just a cut-free list, and one of the lists is implied. We have a bunch of points in space and connect them with edges, and then fill in faces to make polygons. So it's 3D modeling is just connect the dots, and the edges and the faces, one or the other of those will be applied. If we have enough edges to make a polygon, then the faces would be implied, and if we have the faces of a polygon, then the edges are implied. So to list, if I turn on word wrap, excuse me, we can really see how long that is. So points in space, XYZ point, and there's one spot 1 and spot 2, and you can see it's really long list, a whole bunch of points. But I did not sit there and type all those. I used normal modeling software, built the starter file I wanted, and then I used a list comprehension to grab all of those vertices. And then what this is there's a polygon that uses index 909 from the vertices array, index 882, index number 2, which we could probably find that one here pretty quick. 0, 1, index number 2. So this one's used in that first polygon. And then in 95. So those 4 indexes from this list, which are three-dimensional coordinates, go together to make up a polygon. But I did not want to type all that. You can see what happens to the scroll bar when I turn on word wrap. I certainly did not want to type all those points in space. So what I did is use modeling software, and I think my notes are on here somewhere. Zoom thumbnail. Notes, yeah. So I use Blender, so I just created the list from a comprehension. So for all the vertices in C.object is the model. Drag and mouse around in Blender to make a three-dimensional model of it. And for every XYZ vertex in space, put those in a list, and then write that to the file. And then notice there's nested lists. So now put together a list of all those vertices for every face in the polygons. So nesting list comprehension. So a very useful thing to pull from an existing data, right? Dragging around the mouse and the pins on the tablets and all those nice editing tools to make a nice three-dimensional model is a data set. So then I can use list comprehension to very quickly turn that into list that can be used in a future script instead of trying to type all of that mess in. A very immensely useful tool for writing Python code. List and then generators are similar. If we're going to, kind of do like a set, we want all of those numbers every time. So let's not even bother saving them. Let's just figure out what they are as we need them, one at a time. And that also spreads out the delay. Instead of a bunch of small delays as we calculate what each value is and then put it in a list, those small delays are spread out amongst the whole time, so that if our conditions stopped when we found the thing we're looking at, we might get there a few milliseconds quicker. useful tools. You will find lots of uses for that one. 5 to 8. So right on track with the time I was thinking. There's another thing along with collections that I feel is kind of one of the fundamental points of a programming language. Very much related to collections, because collections are in RAM, right? That's over in random access memory. As soon as the program stops, we're going to delete that, or best cases, the computer might not need those spots in RAM, so it'll stick around until another piece of software does need those, which I guess is one point on efficiency, right? Our software might it might be quick, it might be small, but if we use a lot of resources, I hit Windows X and open Task Manager. At any given point, there's a lot of things running on our computer, right? Here's all the applications that are running. Scroll and scroll and scroll and scroll, and it just like keeps going. And not just those, there's not apps. This one, the services. So not just the applications, all the other stuff that's running in the background, applications, services, tasks. There's a lot of stuff going on in the computer. So when we start talking about inefficient software running slow, it's not just our software. Because let me go back to the general one. Everything there. Maybe somebody's got a Spotify running. And if our software starts using up too many resources and Spotify can't play the music correctly, they're going to notice that pretty quick. And it won't be long until they put 2 and 2 together and realize that their music starts, their favorite music starts glitching out every time they run our software. How long is it going to be before they uninstall our software and look for another one that does the same thing, but doesn't make their music glitch out? So even though computers get bigger and bigger and faster, it's not just our program that has to run it. All that stuff on the computer is using the same RAM chip. So if we waste RAM too much and start messing up other things on the computer, people will notice and really be very displeased with our software. I'm going to go ahead and save this file. This is persistent. So along the lines of those collections in RAM, we might sometimes want to put things in long-time storage on the hard drive. That way, after the program's done, we shut down the computer, come back a couple days later, and that data is still there. So I consider writing files part of one of the base aspects of a thing. So the basic idea is a file handler. I'm drawing another picture on the board. So this is only half an analogy, but old equipment, which you may have seen in like history books or museum or something, is actually works a lot better to explain file handlers, the difference between a file and a file handler. Everybody's seen those old reel-to-reel tapes, the reel-to-reel machines, like when it was stored on tapes, like 1960s. Old movies, maybe. They have 2 great big wheels. And in between them, we have that tape running, which was modified slightly, but it really was just pieces of iron between 2 pieces of Scotch tape. That's how it started. And we split that up into a bunch of 1s and 0s. I'm going to write it that way, not completely accurate. We would go lengthwise. So like an inch wide tape was, I think, holding 4 bits. So we could fit 32 bits, 4 bytes. So we could fit 32 bits across an inch. But I'll just do 1 for simplicity here. And we'd have 2 magnets that we run them by. Really 1 magnet. I'll draw 2 magnets to. So we move that back and forth, and there's these 2 magnets. One of them is held stiff, Can't move that. And the other one's on a spring. So the one that's held stiff is the right head. And obviously the one that moves is reed. So when this magnet is held stiff and we run this, it was scotch tape with iron, like powder iron between it. So when it runs past a magnet, that magnetic field turns those little iron filings, right? The north-south polarities. Everybody seen a magnet before? I guess I should check that. So when the magnet's held stiff, the iron inside of that tape turns and picks up the magnetic field that we are transmitting there from our machine. This is back in the days of the old vacuum tubes and heating coils, and way back in the day. You've probably seen it in old movies at least. And the reed head does the opposite. It's on a spring, so the right head magnetized all those iron filings. So if it moves past the reed head, that magnetic field bounces that magnet up and down. So we can pick up what's on we can pick up the magnetic field we stored there. So the reed and right heads go together. Really, it would be one piece, and we'd switch whether it was held stiff or bouncing. Right? But for clarity, I drew it here. But that's how those would work. So there are two things here. There is the data itself, which is on the magnetic tape, what we stored on the tape, and there's the thing that interprets it, reads it, or the handler. So these read-write heads are the handler. And the magnetic tape itself is holding the file. There is a distinction. It's a small distinction, but it kind of makes a difference. So essentially, the handler is the thing that can see the data in the file. We work with them separately. So with a file, all we can do is like this picture. All we can do to change files is take this tape off and put a different tape on. So like copying and pasting the file to a different location on your computer, right? You copy it out of your downloads folder and paste it in your documents folder after you grab something from the internet. Or cut it out of the documents folder and put it in the trash when you're done with it. We move all that data as one big collection. That's the file. And the file handler is the thing that can see the data inside and then transmit what it sees back to the actual processing unit. A small distinction, but for software developers, that does make a difference. Because sometimes we will be working with files and we will be doing things like this, jumping ahead, if os.path.isdir. So if it is a directory, a folder, then we want to do something in the condition. That's working with the file itself. What I want to look at today, we will see that in a couple weeks. What I want to look at today is the file handler, right? Kind of like the list. We take that stuff we stored in a list and write it to a file so that we have it saved to use later. Kind of an important thing. You probably saw something like this. H is open, and then we pass in the file name. I did H for handler. I'm getting ready to delete this line. I'll spell it out. Handler is open testing123.txt for write mode, and open it for writing, and then we'd say handler.write file or .write hello world, line break. That's all for now. Line break. Has everybody seen that? Is that what you saw in your previous class? I believe the textbook in use does something like that. No error messages, no outputs, but if we go over and look at the File Explorer, zoom buttons are in my way, there we go. there's that testing 1, 2, 3. I can open it up. Oh, nothing came through. This is a common issue, right? This is actually manually coded in, and most of our languages do it. Right? According to our output, there's no errors. I feel like that code's correct, right? I feel like we wrote our code correctly. There's no errors, but there's nothing in the file. Because has anybody ever done? We can do this sometimes, right? I want to add another line of code. Print hello world. I'm trying to add something to the script, and look where my cursor is. Over in the console. You ever done that? Start typing in the wrong spot? That's an easy thing to do, right? We are humans. We're intelligent. We will notice when we do that and make the correction, move the cursor over to the right place, and correct everything. The computer is not intelligent. It will not notice if it's writing in the wrong spot. So one of the most important things anytime you open the file handler is to remember to close it. So if you think all your code is correct, this is a standard that was manually worked into all our programming languages because it makes it easier to see. You think your code is correct, no error messages, but the file is empty. That was what people decided is the standard. Oh wait, I have to run it again. We close those. Let me hit run after making that change. That is the standard indication for you forgot to close the file. If nothing shows up in the file, you probably forgot to close it. That is standard across most of our programming languages. There's other syntax. That's what the book in SDEV 140 uses right now, so that's what y'all probably saw. I prefer this syntax. So keyword with, and then we do our file handler, open, testing 123.txt for write, read, or append. Everybody seen those before? Let's do write as handler to kind of make it the same. I almost always call the file handler either to file for writing or appending or from file. I almost always use those names, but for consistency now and clarity in the example, I'm going to use handler. I prefer this syntax. See how it's the same thing? Instead of handler equals this function. This is what feels to me like Python syntax, I guess. We have keyword, the part that's unique to our situation, a semicolon, and then we indent all the stuff that we do here. So write is overwriting. A is append. I should make a list here. W for overwrite. A for append. And R for read. Those are we also have WB, AB, and RB for read and write binary. We'll see that in a couple weeks when we actually get to the writing file section. I like to include at least basic persistent data in the core syntax of the language. But just like our if else and our for loops, that's what I think of as key Python syntax. Keyword, something unique to our situation, a colon, and then we indent the stuff. This has basic error handling in it. This automatically closes the file and has a little bit of basic handling built into it because this is the syntax for dealing with files. Then it's the same thing we did up here, handler.write, .write line. I like to do .write and then put the line break in myself. I prefer this syntax in writing files /n/d in Python. So I'll just do all that. Why did I get an error message? Oh, I spelled handler wrong. All right. Fix the little, there was a little red X showing up there. Fix the little red X, no error messages, but when I go open that file now, we see the latest version. It automatically closes it. There's some basic handling built in there. When we get to exception handling, that doesn't mean you can leave out your exception handling with block. I wouldn't rely on it outside of if there's other things that could go wrong, you don't necessarily want to rely on it. With open same file, testing 123.txt in read mode as from file. I usually use the words to file and from file, calling them, I guess I could call it handler again. I'll call it read handler. We can say, then we use a for line. So that for, really think of it as the for each loop, for each line in the file. That's the natural organization of a text file is lines. So that's where Python's going to split it up. So for line in that read handler we just created. Print line. Another use for for loops, so I guess that kind of goes nicely with that. Has everybody seen something at least similar to that before? If not, reading and writing files is actually further ahead. I just wanted to kind of go over it a little bit. And when I was making a plan, I had 20 minutes left, so I was like, oh, I will work it in there. So you can see here's where we read the stuff back from the file. Append adds it on, so if I change this to an A and run it, notice this time we get all those words twice because it just added more at the end. I'm just keeping this right. Any questions about the basic file writing? And then our basic persistent data, the one you should have seen in SDEV 140, but sometimes that's one of the first ones that gets dropped from 140 and 120 when time gets tight. So you may not have seen it. Is what's called sequential text files. We keep track of the data we put there based off the order we write it. So right, maybe we have 3 data points. X is 3, Y is hello world, and Z is true. Some random data points, whatever they are, and I gotta add white space. White space for scrolling. And that's just, I don't like working at the bottom of a screen, personal preference. And extra white space down there so I don't have to is easy to add in. So maybe I want to write this to a file. So with open my data, and we make up the extensions. Everybody know that the part before the dot is for the human. The part after the dot tells the computer what it is, and we can make up an extension. So I can make up a .sdev. That sounds like a good file type. Fits our thing. My data.sdev for our class example. EXMP might be a good extension for example, but I have a feeling EXMP is probably used somewhere. I'll write some data as to file and to file dot write X, to file dot write Y, to file dot write Z. So this is what we would call a sequential text file. We can keep track of the data based off the order it's in. Do I need to cast those? Oh, they're casting the strings. We'll talk about pickling soon. That was a verb that when they built Python, that was the way we referred to getting things ready to move to a text file. That verb went out of fashion, but Python still uses it. We have to pickle our data in order to get it ready to send to stuff. I'll just cast it as a string, kind of same thing. So we wrote that data to the file, and when we need that later, we can open that file. So I'm just going to copy, right? We know this line worked, so I'll hold shift and hit N to copy that line. And making typos is a human trait, so copy and paste as much as possible. We know this line works, so we might as well keep the part from it that we know there's not a typo in. And we'll do from file, and here write that back into the stuff. So like X2 is for line in from file. And here probably want to enumerate that. So for I and line, and enumerate whatever that file handler sees. Right? It's not the file itself. It's just what the thing that can look at the file will tell our processor what it sees. If I is 0, I'm pretty sure this starts at 0. This might start at 1, but it'll give us an error if it does. We'll say X2 is from file.readline. Wait, line. We'll just read in the line we see. If I equals 1, Y2 is line. And if I equals 2, Z2 is assigned whatever's in that line. So see how we keep track of it based off the sequence we put it into the file, the order. So sequential text. That's where the name sequential text file comes from. Oh, well, I'll just do this different. I know how many lines are there. So instead of the 4, I'll say X2 equals, I didn't read the whole message. Something went wrong. I'm not sure what went wrong, so I'm going to try a different algorithm. X2 is from file.read line. That's one we have built in. So that's going to read the line and then move the cursor to the next line. And we know that the Y value is on the next line. This is probably a little bit clearer than what I tried to do the first time. I thought of it halfway through. So as soon as I saw that error message, it's like, I'm going to go to the other one I just thought of. That's probably a little bit clearer for the syntax, right? And then we can print those. Print X2, Y2, Z2. What? Oh, whoops.
Oh.
I should have read the message. Maybe that first one would have read. Look, I just jumped over to what I thought would have been clearer, which I still think it's clearer code, but does everybody see the problem went wrong? If we look at the error message, not readable. And that comes from right here. I said to open the file for write mode, and computers can't do 2 things at a time. It can't read and write at the same time. So we need to open it in read mode. Sorry, that was just a typo. And when we run it, we see those our three outputs, our 3 data points. We would start doing stuff with it. So that's sequential text file. That's the most basic way. We also have some better formats, some more standard formats, such as CSV files and JSON. Has everybody encountered those somewhere along the way? Comma separated variable is what it originally stood for. Nowadays, most people say comma separated value. That's what spreadsheets were built out of. So think of organizing our data into a grid in the file. And JSON is like the dictionaries we saw earlier. JSON is the JavaScript version of a Python dictionary. There's a few differences internally. If you're looking at 2 of them in code, unless we are passing functions, if you just see the text file, until you get to passing functions, you cannot tell the difference from looking at the text file between JSON and a Python dictionary. So JavaScript is sort of JSON is a JavaScript thing, but it corresponds to a Python dictionary very, very closely until we start putting functions in it. the functions happen a little bit different because JSON is actually an object, not a collection. But if we use it as a collection, it looks exactly like a Python dictionary. We don't put any functions in. So for those, we would have some sort of collections. Let's do a CSV file first. So I'll call it bunch of data or data, however you want to pronounce that. Bunch of data here. I'm just going to put some random numbers, 12, 99, 85, 75, 88, 13. Random numbers that won't really matter too much what they are. And then there's a library module included in Python, the CSV library, for dealing with comma separated values or variables. It was originally variables, but since CSV files are so common, people that aren't technical computer people just interpreted that to be values. We could do it in a text file and just add our commas ourselves. We have something to work with. For these, we would do our file handler. So with open, probably want it as a CSV file because that's a particular thing that most software already knows. When we look at files, we will compare sizes between JSON and JSON is probably our most common way to transfer data across the network. CSVs are our most common way to transfer data in general, in any format. But JSON is JavaScript, so JavaScript is the standard for web pages. So if we're sending it across the internet, we typically use JSON. CSV is considerably smaller, and most software includes CSV, but we'll talk about this in detail later. I just thought I'd go ahead and show it because, yeah, when I made the plan, it was about 20 minutes short of where I wanted to wrap up. So thought it would fill in time nicely. Let's call this bunch of data.csv. We'll open that for write mode as to file. I'll go ahead and give it that name again because this was a local variable. So it only existed until we finished that local block of code. So it's open to use again. And here, so now, I suddenly drew a blank on what I wanted to look at. Will this open in that menu? Oh, no, this doesn't have a help menu. So let me pull up the documentation. CSV in Python. Goes right to the docs. This is what you all are going to do anyway, right? Open this CSV file in some format as this. So they show that. That's a reader. I want a writer. This is that CSV module dot writer. That's what I couldn't remember. My mind, I was suddenly thinking of something that involved curly braces, so I knew I was thinking about the Java version of this. It's like, oh, I better. Now's a good time to go look it up because this is what you all are going to do when you write your code, right? CSV module dot writer, and then we pass in the handler, and then the rest of those look like they all have default set. So we just need the handler for it. So two files are handlers. So I'll call it writer is going to be CSV dot writer, and CSV writer needs to know what handler. So the thing that can see a file, what file can this look at? And then we have a writer dot write row. And then our row, if we're going to a CSV file, well, we can cast in a list. Our list is comma separated. So we need some sort of comma separated list, which is basically all of those collections we saw earlier would count as we need some sort of collection. We'll write a bunch of data to that. I'll give that a run. No error messages. No news is good news. So we come over to our file explorer. Should just let this open. Notice the CSV file, that icon probably looks familiar. It's set to open with Excel, so this stores our data this way. When we get to writing binary data is similar to this. I often like to debug with the CSV file. No, don't sign me in. I like to debug with the CSV file. Oh, it did sign me in. And then switch to a binary file for the final version. Notice how everything's separated. If we open that with the text file, you'll see where the name comes from. Open with Sublime. We just separate all our things, and then there's another row each. So it should make a nice little grid, right? We'd have headers across the top saying what each number represented, and then all of our rows kind of make up like a database table. And think of it that way. It's a standard format that we use in lots of software. We'll talk about it more later, but I thought I would just go ahead and show it because we had a little bit of time and basic file writing was on the plan with 20 minutes left before I wanted to actually wrap up tonight, at least as far as the plan goes. Open it for read mode as from file, and this will be something similar where reader is going to be csv.reader. And we can see here what file are we trying to read. It doesn't have to be comma delimited. Delimited means separated, so we could use we could set up any separator we want, spaces, tabs, dashes. We control what that character is, but comma is the default one, and that's what I wrote it with. So I'm going to do this from file. And now it's going to read all of those in, so I'm going to do a for loop. So for row in reader, I'll just print row so you can see what we get. This is one thing to watch out for. We'll talk about this more later, but notice how it printed an extra list. Let me put 2 lists in here. More data is A, B, C, and then we can also write writer dot write row more data. Which, sorry, I forgot about the zoom. Spider will not stay zoomed in. I forgot. Please remind me if I forget to zoom in, because since you all are reading the examples, Spider resets the zoom with every file. There's probably a setting for that. I've just never bothered to look where it is because Control Plus works really well. So notice that if we come over and check this out in a text editor, that way it doesn't try to log me into that. It gives us an extra row between them. So when you go to read it back, just account for that extra row. It spaces it out nicely, but that's an easy thing to skip. Right, check for a list with length of none. Oh, we haven't seen that. Might as well do that here. If length, that's how we check the length of a list, a dictionary, a tuple, all of those things we saw earlier, len, and then pass in the list will give us the length of that. So if the length is not equal to 0, right? Because we can see here, 2 of those lists have length 0, no elements in them. You'll want to do that. Might as well just show it instead of telling you all to worry. Warning you all to worry about it. Actually, look at that. JSON. If we want JSON data, that's similar. We probably want a dictionary though. So let me some data is a dictionary with a name. I am just making up names here. These are some of the standard names I use. Sally, age. For those who haven't had me in class before, whenever we start working with data and get into tables, or we work with a MySQL table or SQLite table or SQL Alchemy, the ones we use this semester, are relational databases. My standard example is name, age, town, and favorite food, and just completely make up values. These are made up people. So Sally, age 23, from the town of Salem. Yeah, I'm gonna add another. Oh, and we can split things up. You can split things after a comma whenever you make lists, so if they get long. So I want to do a couple items in the dictionary here. So we can split them up after a comma to make them more readable, which I'm just gonna copy that row, paste it a couple more times. And what else do we have? Chuck, age 58, from Charlestown. Just making people up here, not real people. Lewis, age 14, from Louisville. There we go. That gives us some data to work with. And notice it's a dictionary, right? It's a collection of dictionaries. Actually, I could do it as a list. There are a couple ways. I'll leave it as a dictionary. We probably want to do this as a dictionary. We can import this JSON data or JSON module and then open a file. So with open some data.json, that's one of our standard formats. So probably want to stick with we don't want to make up an extension for that. For writing as to-file, we've seen that a few times now. Do JSON.dumps. Actually, let me pull up the book. JSON and Python, we look here, import JSON, and we have dumps. There's also dump without an S. And same thing when we bring it back, we have load and loads. And that really is like plural. Dump would be a single data point. But we usually have more than a single data point. Or if we make it plural and dump a whole collection, there can be a collection of one thing. So use the S on dumps and loads. And remember to look things up, and here where we're learning Python, get some practice with the official documentation, look at it. It's probably very confusing, but that's the user manual for Python. So you want to be able to read that, because the people that write the user manual for Python are really, really good at writing computer code. And a lot of times not so good at writing English sentences, especially English sentences describing computer code. So all of our programming languages are like that. You want to get some practice with them. So JSON.dumps, and then what are we dumping? We're dumping some data. And then the with thing will automatically close it. So if we run that, whoops, capable types. Maybe it doesn't like that. Let me try switching that to a list. I almost did this earlier, but then I was like, well, maybe it'll be clearer if I do it this way. Okay. So since I did not have a key for all of these things, it didn't like doing that as a dictionary. So I changed it to a list filled with dictionaries, which is probably a good example. We didn't nest any of our collections earlier tonight, right? So we can fill a list with dictionaries and JSON.dumps. Apparently close File Explorer again. Should give us a .json file here somewhere. Some data.json. My computer doesn't know what to do with, but if I open that with, say, Sublime, why didn't I get anything? Well, let me go check documentation. So, where's the dumps? Import JSON, JSON.dumps, and then we tell it what we want to dump in there. So notice how we didn't use this file handler anywhere. So JSON.dumps simply converts the Python collection to a JavaScript collection, basically. We still need to use our file handler. So to file dot write JSON.dumps. See if it likes this a little bit better. There we go. So you can see it put all of that in there. File Explorer. I believe I have a plugin. The plugin should come with my Google account, right? I have a plugin for Pretty Print JSON. Pretty Print is just the nice formatting. So open with browser. First browser. I seriously have to look for that. Okay. Copy file protocol / that address. It's actually going to be problems in Chrome. Microsoft backslash and addresses have been causing problems since the 1980s. I think they would have fixed it by now. Slash some data.json. I'll just open it from it. Is that the name of it?
With an array slash between delete.
Yeah. Thank you. Delete slash SDEV. There we go. Oh, I don't have my plugin. This is a new computer, so I probably, oh, there we go. Should be on there. Why is not? Need to see information. Okay, well. Okay, I don't know why my plugin is not working. That should do Pretty Print where it does line breaks and indents and stuff. But I haven't actually used that since getting the computer, but I'll look into that before we get to REST APIs. That'll be important. That's how we transfer our data in RESTful APIs. But reading it should be straightforward here. You can probably actually when you look at it now. Let me put my cursor here and hold shift and hit home. And here, I like to put, well, I'll do it here on this line. This isn't the line I want to copy yet, but it's indented. So I put my cursor just anywhere in this line. And then I push in to get to the end, then hold shift and push home. Because if we hold shift and hit home again, it toggles back and forth between the indent. So I always like to do in first. So click in the line we want to copy. Hit in. You go put the cursor at the end. Shift home highlights that line really, really quickly. If you're not using the keyboard more now, you probably want to, right? We only have 2 to 6 buttons on the mouse versus 120 buttons on the keyboard. We have way more control with 120 buttons. Just takes a little while to learn to read them. And here, X equals JSON loads 253. I think I'm gonna do that quick. Print X. Let's see if that works. Yeah, that'll get it back in. There's multiple ways to do it, but hopefully that was at least close to something that you would have guessed. If you get something slightly different, try what you would have guessed in that example, because there's more than one way to do that. I just wanted to include those because CSV and JSON are much more common ways to write data. If I come over here and confirm, notice that JSON's 158 bits, 158 bytes, and that CSV one is 28 bytes. So CSV is smaller. Pretty much any database you have, any spreadsheet, any reporting dashboard software like Power BI, things like that, they almost want to default to using CSV files. But since JavaScript is an international standard on websites, that has become a very, very common way to transfer data across the internet, because somewhere along the way it's going to encounter some JavaScript, so it's already ready to be processed there. And to process it for Python, to get it to the other side of the internet and get it ready for Python, it's just JSON.loads. So most of our processing these days is going to be done with Python or JavaScript. So that's why JSON is so common. When is it? Module 4, I think we will make a REST API. So we will transmit data across the internet, and you probably want to do that in JSON format. This is what you do on the other side. Your homework assignment for that doesn't actually do anything when you get it to the other side, but you just have to do the transmitting part that hopefully you can easily predict that after a classroom when we're not under tight time constraints anymore, you probably want to do something on the other side too, not just transmit it across the internet. You don't want to do the transmission side. You want to do the transmit and receive for your software. That was a bunch of stuff, a bunch of collections about working with data. Hopefully, see, you might think there's a bit more, perhaps like preview of 200 level programming course versus the 100 level you had before. What should I do? I'm gonna here in the GitHub. I'm gonna use that local desktop application I like. So Sublime Merge, that's the one I like. Which the shortcut is Smurge. So I just want to open Smurge with the current repository. Nothing to commit, so we need to stage all the files. All those files we made, stage those. But at this level of course, there's going to be a lot more working with data. That's why I wanted to make sure that data explicitly stated. That is why data is included in the core syntax of the language here, because we're going to do a lot more processing data sets than what you would have seen in the 100 level class, where you're doing a lot more small calculations based off the immediate input stuff. Our immediate input is probably going to be all that. So stage all that to that, commit those 7 files. Please enter a message. First, a bunch of collections. A bunch of collection stuff. Commit those files and push it up to the remote repository. So that example should be on GitHub now. Before long, we'll stop checking. I'll go ahead and open GitHub. Look, GitHub, and our last example, SDEV 220 is here. And you can see some of those commitments were made within the last minute. We can go in there and see all the pluses and minuses. Actually, we haven't subtracted anything yet. If we take stuff out, it turns red. You may have seen that on your repositories. But we can get back to the full history and all that. Desktop applications for Git are kind of nice. They put everything in a GUI so we can click around and do things. Anybody have any questions about that? And I will point out that we will see every bit of that again, right? And it's not like that was the only time we're going to see it, and I'm going to expect you to remember it the whole semester. We're going to see that stuff over and over and over again, because at 200 level, we do a lot more working with data. We will tie into databases. And I've already used the word a couple times, data structures. A database is storage, your hard drive. A data structure is RAM, memory. So we use both of them. That's the short version of it. Databases you've probably heard of. That's long-term storage, but we need to get it from storage into memory, through the processor, and then back out of memory as quickly as possible. That's what data structures are for. We're going to spend a while with those. So a whole lot of this class is going to be about working with data. So we will definitely see all of those things again. Anybody have any questions about them? Get some practice with them. That's an important thing, right? It's an active subject. We learn by doing. We have an hour and 6 minutes left tonight. from what should be blocked off on your schedule for learning Python. So a great time to, if you haven't seen lift generators and comprehensions before, to maybe give those a try. See what you can do with those, or whatever you want to do. As always, I will be basically waiting for questions. If everybody leaves, I will probably drive back to Clarksville, so there'll be about a 10-minute gap. And Ivy Learn inboxes and text messages are the only two things that make noise on my phone. So when classes are running, I'm basically set up to hear from you all. Everybody else has to wait until I get around to seeing the message. I'm just going to be sitting around until 9:50, waiting for questions to come my way. Unless everybody leaves and I'm the last person on campus, then I will take. I say 10 minutes. It's probably less than 10 minutes. It's 2 exits up the interstate for those who live elsewhere in the state. I live on Applegate Lane in Clarksville, so I drive. Speed limit's what, like 80, 85? I get back there really quick, get up 2 exits really quick, and then I am maybe 500 yards off the interstate exit. So it does not take me long to get home. Otherwise, I will just be sitting here waiting for questions. Let me know if you have any. Otherwise, everybody have a great weekend, and I will see you on Monday.